So now we can move on to setting up our first toolpaths. The first thing we want to do is cut out our locating dowel holes. So to do that, I will go to 2D and I will select a 2D pocket. And within here, the first tab it brings up is the tool selection. So I can come over here to Tool and select. And I will be using my cloud tools and the wood tools. You should have these in your database from the previous week's lessons. If not, you can right-click on the wood tools and import the library. And the library is located in our data panel under CNC tooling. And you can download these and then re-upload them into the file. So back to our 2D pocket. And the tool I'm going to be using for this entire project is going to be this 1/4" ball radius bit. So I'll select that. And one thing to notice here, the flute length, the overall length is 1¼ inch. And that's going to be crucial later on because our overall material thickness is 2 inches. So we cannot mill it all the way down to the bottom. And that's fine because we don't need to. We only need to go about 1 inch down to achieve our profile. So when I select the tool, it automatically populates the feeds and speeds, and we'll leave those defaults alone. The next thing we'll do is select the geometry to be milled. So we'll be cutting these 2 interior pockets. So if I scroll down, I can select the 2 circles on the inside. We can take a look at our height offsets. So it's showing us that the default top of material is the top of our part. And then the next plane up is the rapid down to. So it's as it traverses over, it'll use a faster speed to bring the bit down close to the material and then slow down as it goes into the material. And then this up here is the rapid traverse, which is it's going from its home position to the cut position at that height, at that Z height. We can leave our default height settings alone. We'll take a look at the passes tab here. So within the passes tab, we have the bit compensation, which is a choice between a climb cut or a conventional mill cut. If you hover over it, it gives you a pretty good explanation of what those two are. The other tabs are not going to be very critical for what we're doing at the moment, so we'll just leave them alone. The default stock to leave tab is something that we're actually going to deselect because we don't need to leave any stock at all. We're going to be milling it completely this first go around. You use this when milling harder materials like aluminum or steel, and you want to have a much more precise final pass. So we'll deselect. Now we do want to get used to using multiple depths. If we don't select multiple depths, it will do this operation all in one pass. And for the foam, that's probably going to be just fine, but it's a good habit to be conservative early on and do it in small incremental passes so you can see if anything's going wrong, and you can always speed this up and make it deeper later on. So we'll select multiple pass. The default is 0.04, which is really, really small amount, but it'll still run fairly quickly because it's not rotating very far around this circle here. So we'll just leave that alone. The last thing is for cutting holes like this, we need to remove the lead in, lead out, which is it's the the tool doesn't just plunge straight in. It has a lead in that softly puts it into the material. But for the holes, it gets in the way and it actually ends up cutting away more material than what we want. So we can deselect these. And the ramp in style we'll just use a plunge in ramp style. And we'll say, okay. I'm getting this error with the specific tool, the ball tool. I'll say yes. And I found that for some reason or another, the ball tool will not work with this operation. It gives me a hard time. So what I'm going to do is cheat a little bit, and I'm going to come back in and select from my wood library this 1/4 inch flat. And it should still achieve the same thing that we're looking for, but for some reason the program allows it to work, whereas it doesn't allow for the ball to work. Say okay. Now I'm going to get a different error with the flat tool. No passes to link. One warning. So what it's doing is it doesn't like it either doesn't like the geometry I selected, or the diameter of this hole is exactly 1/4 inch and the diameter of the bit is exactly 1/4 inch, and it's not liking that. It could be that it doesn't like either one. So what I need to do is start off by going back to the model space. I'm going to revise this hole size, and I could do that in the sketches, my body wide sketch, and I'm going to give this a value of 0.26. That's a super small increase in the overall dimension, but it should allow for the bit to run. Close that, go back to manufacturing, and it started showing our setup board there. We'll get rid of that. Now we'll regenerate. So up here in actions, you can come up to generate. We'll see if it accepts it. So there, it accepted it without error, and that's a good thing. That looks pretty good. The next thing we're going to do is mill this perimeter pocket here. So to do that, I will use the 3D dropdown. And there's two different options here, or actually there's a bunch of different options, but the two best options are the adaptive cleaning will remove all material on the plane that we mill down to. And if we were making this out of, say, aluminum or even wood, we would want to definitely use this adaptive cleaning. It removes material that the machine could potentially run into later. But since the adaptive cleaning adds quite a bit of time, machine time, in this instance, it'll add about an hour of machine time. And since we're using foam, it's not absolutely critical that we use the adaptive clearing. So I'm going to go ahead and go straight to either I can use the parallel, contour, or even the ramp. I'm going to use contour, and what it's going to do is it's going to mill this profile at a given Z depth per pass. So it'll just keep milling around and around and dropping down the amount that we define as far as the Z drop down. So I'm going to select a different tool than our default selection. So I'm going to use this. I definitely want to use the ball end mill. Hit OK. Now we'll come to our geometries. Now the first thing I'm going to do is select the model to be cut. And I can select either surfaces, or it's easier just to come up here and select the entirety of the model. So I'm going to go car body. And then the boundary, we can draw a box. We can use the silhouette of the model. Or we can have a selected boundary. So I'm just going to use the silhouette. Now the tool orientation, I want to mill to the outside. I want it to complete all of this machining. If it's on the center or inside, it will stop at the, the bit will not go beyond that, the center line of the boundary. So I want to make sure I select all of that by selecting the outside of the boundary. And just to see what it does, I'll go ahead and say, okay. And it takes a little bit to generate. And we'll see, we'll get an idea of what it's going to do here in a second. So it actually looks pretty good. The main issue that I'm seeing is that it's machining all the way down to the bottom of the surface. And from what we discussed earlier, we don't have the available tool length to do that. We'll actually hit this here represents the collet. It will start to rub on our material. And again, with the foam, that probably wouldn't be catastrophic. But if we were running wood, there's a very good chance that we would start a fire or eject the part. If we were running with metal, there's a pretty good chance we would completely destroy the collet and also potentially eject the part. So we have to be very careful at this step. To modify that, we'll go back into Contour and edit. So we know that our general process is good. We'll go into this Heights tab. And now we can see that the bottom, we need to reset this bottom size here. So we want to give this a value. We want to come up about 1/2 inch. And we want to bring it all the way up until it starts to hit really close to this tab here. So I'm going to go 0.6, and that looks pretty good to me. So if our overall bit availability is about 1.75 inches, and we will be dropping down about 1 3/8. So that should be good. Now the next thing to look at is we have this option for stock to leave. If we wanted this part to be pristine out of, say, aluminum, we would do this. We would leave stock and then come back and do a final cleanup pass. But again, this is really soft foam that we can sand out, so it's not real critical that we're leaving stock for a later operation. And the max step down is pretty small. It's 0.04. So we'll go ahead and leave that default step down, because again, like, this foam is so soft that it's easy to kind of buff out. If we wanted this to be super smooth, we can go all the way down to 0.01. And our linking parameters are good. We don't really need to mess with those. The feed optimization, I don't know exactly what it does, but it seems to give us a smoother overall program. So we can go ahead and select that. It'll regenerate. And we're looking for it to mill down to this surface here. In regards to the feed optimization, I think it sounds cooler than not being optimized. So that looks about right to me. It's going down to a depth that we need. It's still going to cut slightly beyond our end of our vertex here. So the last thing I'm going to do as the main double check is I'm going to simulate it by coming up here to Actions, Simulate, and I will hit play. And I really want to speed this up so I can bring this over. I'm going to rotate around. Now, if we had chosen to do adaptive clearing, we can remove all of these kind of towers that are being created. And those are important for tooling life if you're doing harder, more difficult material. Again, for us, it's not really all that critical. And it looks like everything's good except for these little nubs here. Not sure why it's doing that. So I'm going to close this out. I'm going to go back into Contour. And I'm actually going to deselect this feed optimization. And I want to go ahead and change this step down. I'll see if this doesn't improve. So what we see on the simulation is pretty much what we're going to get on the machine. So sometimes it takes going back and forth quite a few times to get it where you need it to be. The main things to consider are the length of your tool and that you're actually removing all of the things that you need to remove. So it still looks like it's leaving that nub in there. So we'll go to simulate, play it again, and we'll speed it up. Even with this within the simulation, you can see the ridges that will be created from that 0.03 step down offset. There it goes. So it left a little bit of a hump in there, but just by editing the refinement, we were able to get that out. You can also see the ridges in here. If we were doing this in metal, we would definitely want to clean that up quite a bit. But that's for the foam project. That's going to be just right. So we'll close this. This is definitely a good time to save. We'll save. On the next video, we will look at doing the setup for the top side and doing the setup for our locating board down here and applying the tool paths. In the meeting.